This video will explain how to draw a flow net and estimate the water seepage under engineering structures. We'll start with these textbook examples when we have two water levels, the one on the left and on the right. We have sheet piles here in between, and we're going to have some water seepage underneath that sheet piles. So we're going to draw the flow net for these particular conditions, and we will estimate the rate of seepage. We will start drawing flow net with flow lines. Flow lines show you direction of water flow. In this case, we should understand that water flows from the left to the right because this level is much higher on the left than the one is on the right. There are already a few flow lines in this setup that we need to first find and recognize. So flow lines typically shows you how water flows, and water can flow underneath the sheet pile in this direction. So this is the first flow line, so it's kind of top boundary, and the other one is just here at the bottom. So this is the second flow line that already exists. So now we're going to draw additional flow lines, and we would like to draw them as parallel as possible, as shown here. So you see this is already one flow line drawn here, and this is the second one. So what is important is to keep about the same distance from flow lines. If we measure this distance, should be equal or similar to this distance and to this distance. So this is one of the major rules of drawing flow lines. And the space between flow lines we call channel. So in this case we have one channel here. We have another channel here. And one more here. So we have three flow channels for this flow net. Typically would like to have about from 3 to 5 flow channels. Of course, you can draw as many as you like, but I think about like from 3 to 5 will be enough. So this is the first step, and the next step is we're going to draw equipotential lines. Equipotential lines shows you points where the total height is the same, which means that there is no water flow between those points. So what you need to remember is that flow lines, when we draw flow lines down here, they must cross flow lines at right angle. So they should be perpendicular. So in this case, this is right angle, this is right angle here. Remember that here also we have flow line, and this is equipotential line, should be at right angle. What we already have before we even draw equipotential lines, we already have two equipotential lines here. They already exist for any flow net, this one and this one. So these are equipotential lines, which means that there is no water flow if we put point A here and point B here. There is no water flow between these 2 points. Again, we will follow similar rules that the distance between equipotential lines should be more or less the same, and we would like to draw nice squares. Of course, sometimes we cannot get nice squares like in this case, but we'll try our best to do that. So this is what we call the equipotential lines and the flow lines. And these equipotential lines and flow lines, they will create what we call drops. So this is drop, this is drop. So all the squares defined by flow lines and equipotential lines, they're drops. These are the basic rules and principles that we need to follow when we draw a flow line. Now let's see how we can use this flow net that we just drew to estimate the water seepage, or sometimes we call it the rate of water flow. We use letter Q to define it. So to find this Q, the rate of seepage, we need to use this formula. So there are a few things that we need to know. we need to know the coefficient of permeability, and in this case we're going to assume that it's equal 0.1 meters per second. Then we need to know these numbers. So NF stands for number of flow channels, and ND stands for number of drops. So let's just find these numbers first. The way to do it, we would select the flow channel. First, we'll calculate flow channels for this flow net, and we already know that there are 3. So this one is number 1 flow channel, this one is number 2, and this one, it will be number 3. So we have 3 flow channels, and F is equal 3. And now we're going to count drops. To count drops, typically I would choose flow channel in the middle. So let's choose flow channel number 2, and then we just count number of squares, or like that looks like squares in this channel, and this will give us number of drops. So we'll start from the left where water starts flowing. 1, 2, 3, 4, 5. So we find that number of drops is 5. And now we need to find H. H is the difference in total heads. So we need to again find 2 levels, 2 water levels, and find the difference. In this case, we see that the difference between level on the left and on the right is equal to 1 meter. So in this case, H will be 1 meter. Now we're going to use the formula and calculate Q. So Q is equal to 0.1 times H is 1 meter times number of flow channels 3 divided by 5. So this is equal to 1. And that will give us approximately 0.06. And we use cubic meters per second, no square meters, and we also need to write that it's per meter run. So this will be the answer.